Hey everyone! Today, we're going to talk about something you've probably seen a million times but never really thought about. It's hiding in plain sight, but it's one of the most powerful and versatile ideas humans have ever had. We're talking about the secret life of screws. So let's just start with the basics, right? What is a screw? Now, I know, the answer seems super obvious. But what if that obvious answer is just the tip of a really, really big iceberg? I mean, for most of us, this is what comes to mind. It's a fastener, right? You grab one at the hardware store to put up a shelf, maybe build some furniture. It's this humble little thing that, literally holds our world together. But that's just its day job. Because what if it's also this? A super high-tech tool, engineered with incredible precision, made from crazy materials like high-purity magnesium, all to fix a broken bone inside your body. All of a sudden, it doesn't seem so simple, does it? Okay, let's zoom out. Way out. A screw can also be this massive machine, an Archimedes screw turbine. It takes this ancient idea and uses it to make clean energy just from flowing water. Think about that jump from your bookshelf to powering the grid. And now for the part that's gonna totally blow your mind. A screw doesn't even have to be a physical thing. It can be a completely abstract idea, a mathematical concept. Yeah, there's something called screw theory that helps robots figure out how to move. So seriously, what is a screw? Let's dig in and find out.
All right, section 1. Let's start in a place we all kind of know, the world of building stuff. We'll call it the builder's best friend. But as you're about to see, from crazy new materials to futuristic robot factories, the screw's role here is, well, it's anything but basic.
See, the thing to get here is that screws aren't just the little fasteners you pop in at the very end. No, they're at the absolute heart of how we make things today. That super precise cut in a block of metal from a CNC machine, that's thanks to a powerful screw driving the cutting tool. The amazing, intricate stuff that comes out of a 3D printer, yep, a screw is guiding that nozzle, building it up layer by tiny layer. And in those huge automated factories, it's robots using vision sensors and, you guessed it, screws to put everything together faster and more accurately than any human ever could. Now, check this out. This is a seriously cutting-edge method for making a new, super strong material using things like flax fibers and graphene. But here's the cool part. How do scientists even know it's stronger? Well, they use screws. I'm not kidding. They drive screws into this new stuff and then use machines to pull and twist and push them to their absolute limit. So the screw isn't just part of the final product, it's a core tool for inventing the future. Okay, let's move on. Section 2, the body's mechanic. We're shifting gears now from building things to fixing the most complicated machine there is. Us, the human body. And in this world, the screw becomes one of a surgeon's most vital tools. And the ways they're used inside our bodies are just wow. Surgeons can use a whole bunch of them, pedicle screws, to literally straighten a spine that's been curved by scoliosis. Or they can use these special cortical screws to put a shattered ankle back together. Even your dentist is using tiny little screws to lock in a new implant. And the level of precision we're talking about is just mind-boggling. Surgeons are using things like neuronavigation and custom 3D printed guides just to make sure these screws go in with less than a millimeter of error. Incredible. And believe me, picking the right screw is a huge deal. Just look at this comparison for fixing a broken hip. You've got two different systems. The one on the left, the FNS, means the surgery is quicker and the cut is smaller. That's great. But the really important part is that last row. It has a lower rate of complications. Specifically, the implant is less likely to come loose over time. For the person on the operating table, that simple design choice makes all the difference for a safe recovery. But it's not just about the tech itself, right? It's about the skill of the person using it. Get this. The research shows that for something really tricky, like putting in those spinal screws, a surgeon might need to do the procedure 70, that's 70, times before they're really past the learning curve and the risk of complications drops way down. It's a pretty stark reminder of just how much expertise it takes to wield this supposedly simple tool. All right, so we've gone from the micro level of surgery, and now we're going to zoom all the way out again. Let's look at the screw as an absolute giant, an industrial engine that moves, compresses, and powers our entire world. This right here is the Archimedes screw turbine, and it is just a brilliant piece of engineering. It takes one of the most ancient screw designs ever and just flips it completely around. So instead of the screw turning to lift water up, the water flows down, which makes the screw turn. And that turn, it spins a generator and makes electricity. It's super efficient, it's actually safe for fish to pass through, and it's just proof that this basic helical shape is absolutely timeless. Now, if you look at heavy industry, you'll find this workhorse, the twin screw compressor. These are beasts. They use two giant interlocking screws to compress gas for, well, pretty much everything, from your air conditioning to massive manufacturing plants. And what this chart shows is how engineers can tweak them to get the best performance. It turns out the speed the screws are spinning has a huge impact on efficiency. But other things, like how much cooling water is flowing, not so much. Okay, we've seen the screw as a builder, a healer, and an industrial engine. For this last part, we're going to go completely abstract. This is where the screw stops being a physical thing you can hold and turns into a pure idea. And let's start with a surprise, a quote from a literary analysis. It's about that classic horror story, The Turn of the Screw. Now, obviously, in the book, the turn of the screw isn't a literal action. It's a metaphor, right? It's about turning up the psychological pressure, cranking up the tension. The screw becomes this powerful, abstract symbol that holds the whole story together. This comparison really nails the difference. On one side, you've got that physical machine we just talked about, the compressor. On the other side, you have screw theory and robotics. It's pure math. It's a way to describe any movement a robot makes as a combination of a twist and a push along a line. So one uses a helix to move a substance, and the other uses the idea of a helix to describe a movement itself. Wild, right? And don't think this abstract stuff is just for theory. It has real-world uses. In sports biomechanics, for example, analysts talk about the instantaneous screw axis to figure out how athletes move. So for a pro golfer, that really complex twisting and shifting of their hips during a swing, it can be broken down mathematically into one single elegant motion around an imaginary line. They are literally using screw theory to find the perfect swing. So, where does that leave us? I think it's pretty clear. The screw is so much more than just that little metal thing in your toolbox. It's a fundamental idea, a principle that works at every scale you can imagine, from the microscopic all the way to the massive, from the totally physical to the purely conceptual. It's all about that one elegant shape, the helix. That's the thread that connects everything we've talked about. It's what builds our world. It's what heals our bodies. It powers our industries. And it even gives machines a language to think about how they move. And that just leaves me with one last question for you. This incredible, powerful idea, the screw, was right there in front of us the whole time. It kind of makes you wonder, doesn't it? What other simple, game-changing ideas are hiding in plain sight right now, just waiting for someone to see them in a whole new way?